Hello students, after the completion of preparation of colloidal solutions, now we are taking purification of colloidal solution. Now question arises that what impurities are present in the colloidal solution? Impurities are excess of electrolytes. These excess of electrolytes are removed from the colloidal solution to purify them. How these electrolytes are acting like impurities in the colloidal solution, that also I am telling you. In the peptization we did that some amount of electrolyte is required for the stability of colloidal solution, and due to that electrolyte adsorption, particles of the precipitate remain apart. But if these electrolytes are in excess in the colloidal solution, then they neutralize the colloidal particle into precipitate. Coagulation takes place if excess of electrolytes are there. That's why that electrolytes are removed. So I'm taking different processes for the removal of electrolytes. First process we are taking dialysis. I think you all have heard this term dialysis. In the kidney failure cases, dialysis is done. So how dialysis is done for the purification of colloidal solution here? Firstly, we prepare a bag made up of parchment, made up of animal membrane like animal bladder, and in that bag we fill colloidal solution containing excess electrolyte, and that bag is suspended in a trough where fresh water is continuously running. So as we are suspending this colloidal solution in an animal membrane bag, this membrane acts like semi-permeable membrane, and the electrolytic particles of electrolyte which possess very small size, they can pass through. But the colloidal particles cannot able to pass through this bag. Only the electrolyte comes out through the pores present in the animal membrane, animal bladder, parchment paper. So in this way, excess impurities are removed. Second is electrodialysis. Electrodialysis meaning, students, if in the same arrangement we are introducing two electrodes, cathode and anode, two electrodes if we are inducing and if we are passing current into this fresh water, dialysis process increases, rate of dialysis process increases. Why? Because as we are passing current in this trough having fresh water, kinetic energy of the molecule will increase and more water particles hit this bag, and the more amount of electrolyte comes out into the freshwater trough. So this dialysis process can be enhanced, rate can be enhanced by electrodialysis. Next is ultrafiltration. Ultrafiltration, colloidal solutions cannot be filtered by simple filter paper. All the colloidal particles can also pass through the normal filter paper. So for the filtration of colloidal solution, we require ultrafilter paper. What do we mean by ultrafilter paper? Filter paper whose pore size is highly reduced. So how can we prepare that ultrafilter paper? Normal filter paper is taken and that is dipped in colloidal solution. Question can be asked from this first. What is the composition of colloidal solution? So it is 4% of nitrocellulose in the mixture of alcohol and ether. This is the composition of colloidal. 4% solution of nitrocellulose where? In the mixture of alcohol and ether. Now as we are dipping this filter paper into this colloidal, then that filter paper is now soaked in formaldehyde. What is the function of formaldehyde? Formaldehyde is responsible for hardening of this solution in the filter paper, making it hard, and thus the pore size becomes reduced. That size reduces. Okay, and this whole process of reducing the pore size of the filter paper is called impregnating the filter paper. Impregnating the filter paper. And by the process of impregnation, ultra filter papers are produced which are used for ultrafiltration. So these are the processes by which we can purify the colloidal solution. We can remove excess electrolytes from the colloidal solution. Okay, students, like blood is also colloidal solution, and whatever impurities are there in the blood, whatever food we are eating, whatever waste material is there, which mixes with blood, that is filtered by the kidneys. Kidney are also doing the same process as we have done in the case of purification of colloidal solution. Here, now after this, I am taking properties of colloidal solution, students, and I am saying that one of the property will definitely be asked in your board exam. Properties of colloidal solution, very important. There are many properties of colloidal solution, and definitely one will be asked. So firstly, I am taking optical property. Optical meaning related with light. And the name of the optical property of colloidal solution is Tyndall effect. So Tyndall effect, what is happening in this? Tyndall is the name of scientists. Tyndall effect. What happens in this? I am just telling you the definition. Whenever light passes through the colloidal solution, its path becomes visible. This is a colloidal solution. We are focusing some light by using a torch. Whatever path that light is following, that path becomes visible. So this effect is called Tyndall effect. When a beam of light is passed through the colloidal solution, its path becomes visible. This effect, this phenomena is called Tyndall effect. Now question is, why the path of light is becoming visible? We have done, students, that colloidal particle size is bigger than the true solution particle size. So these bigger particles of colloidal solution, they are responsible for scattering the light. Light get scattered. As the light is coming on these particles, it get scattered. And that's why we can able to see the path of light. So what is the reason of Tyndall effect? Scattering of light done by colloidal particles. That's why the path becomes visible. Now, some conditions are required for the Tyndall effect, and that conditions are diameter of dispersed phase particle, the particles which we are adding in the dispersion medium. Diameter of dispersed phase particle should be comparable than the wavelength of light. Should not be very small than the wavelength of light which we are focusing on the colloidal solution. This diameter of the dispersed phase particle should not be very less than the wavelength of the light which is focused on the colloidal solution. Second property which is required for the Tyndall effect is, second condition, there should be large difference in the refractive indices of what? Of dispersed phase and dispersion medium. There should be large difference. So this is about the Tyndall effect. You know, students, why sky appears blue? Due to Tyndall effect. Because in Vibgyor, violet, indigo, blue, yellow, red, you are knowing that all colors. Blue color is getting maximum scattered, and that's why the sky is blue. Actually, light is coming from the sun in the form of white light or Vibgyor, and the atmospheric air acts like colloidal solution that scatter light, but since blue colored light is scattering the most, that's why sky appears blue. So that is also the result of Tyndall effect. Clear? Now the next property I am taking is mechanical property. Mechanical movement is there. So name of the mechanical property in colloidal solution is Brownian movement. Brownian motion. What is it actually? You have studied this in ninth class also. Zigzag motion. Zigzag motion. It is zigzag motion performed by colloidal particles is called Brownian movement. Again, some scientist is there, Robert Brown. On his name, we call this movement as Brownian movement, zigzag motion. What is the reason of this Brownian motion? Unequal energy collisions. Unequal energy collision. Suppose this is particle A, B, C, D, E, F, and so on. Suppose this A particle is hitting with B, it transfers all of its energy to this B particle. Now B will be having energy of its own and the energy of the particle A which is transferred to it. Energy increases. Now with the two energies it hit the third particle. Now the three energy particles are hitting the fourth one and so on. And that's why the movement never stops. It continues. So this is called Brownian motion, unequal energy collisions. What is the significance of Brownian motion? Significance is, as we have done, that this colloidal solutions are stable. Why they are stable? Because they do not settle down easily. And why they are not settling down? Because of this Brownian motion. They are continuously in motion. That's why they do not settle down. So this Brownian motion is responsible for the stability of the colloidal solution. Next property is electrical property. Electrical property name is electrophoresis. It is also called cataphoresis. What is it? If suppose, firstly I am telling you the definition, movement of colloidal particles towards opposite electrode when electricity is passed through it. Movement of colloidal particles towards opposite electrode when electricity is passed through it. So here I am filling this colloidal solution in a U tube and which is fitted with two electrodes, cathode and anode. As the current is passed in this U tube, movement of colloidal particle take place towards opposite electrode. Like positive will move towards negative and negative particles will move towards positive. And they, on accumulation over an electrode, get coagulated, get precipitated. So this is called electrophoresis. In the applications of electrophoresis, we will study that in the chimneys of industries, two charged plates are fitted. Smoke which is evolving out, coming out from the industry, which contain many poisonous substances into it, that poisonous substances get coagulated in the chimney itself due to that two charged plates. So the air becomes free of pollutants and that fresh air is passed into the atmosphere. So many applications are there of this electrophoresis. We will do it later on in the sewage water dispersal also. This electrophoresis is done to remove the waste particles which are poisonous in nature, which are harmful, so that they cannot get dumped into the fresh water bodies. So in this way, there are many applications of electrophoresis. We will do it later on. So for today, this much is there. Thank you, students.